Alright, so this video we're going to take a look at integrals that are in basic logarithmic form. So here's our formula, I guess you could say here. So all this is that we look here at the denominator, u, and if the derivative of the denominator is in the numerator, then it's the natural log of the denominator, and that's an absolute value, and we can only take logs of positive numbers, and that's where the absolute values come in, and then of course plus c. So let's take a look at some examples. Alright, so in this first one here, well, it's easy to see that if we take the derivative of the denominator, we end up with the numerator. But let's go over here and let's use u substitution and all that stuff and get it in that form. So if we let u equal x plus 1, the denominator, then we can see that du is dx. So all I'm going to do is in the place of x plus 1, I'm going to put u. And so this is equal to the integral of u. And then in the place of dx, I'm going to put du. And you can see that is in the same form that our formula was in. Okay, there's our formula. And so this is equal to the natural log of u plus c. And so now we've got to get this back in terms of x. So that's natural log. And in the place of u, I'm going to put the x plus 1 back in there, plus c. And there's our answer. All right, let's take a look at the next problem. Let's bring this down. All right, so let's look at this one. So in the denominator, see, we see the fraction, and the first thing when you see that fraction, you ought to think into your head, okay, is the derivative of the denominator in the numerator? That's what we want to check. So let's let u equal sine x, and so du, well, the derivative of sine is cosine dx. And you can see we get that. See, there's the cosine x, there's cosine x. And so now we can get it in this form here. So this is the integral. In the place of sine x, I'm going to put u. In the place of cosine x dx, I'm going to put du. See the cosine x dx, here's the cosine x dx. And so this is natural log, absolute value of u plus c, which is the natural log. And then back in the place of u, I'm going to put sine x plus c. And there's your answer. All right, next example. All right, so let's look at the denominator. See if we can get the numerator if we take the derivative. So if I let u equal 4 minus x squared, then du is negative 2x dx. So in this problem, you can see we have the x dx, but we're just missing this negative 2 here. So if we multiply by negative 2, well, that gives us our negative 2x dx, negative 2x dx. But you just can't multiply something by a number other than what number? Other than the number 1. So if I multiply by negative 2, I can also come out here and multiply by negative 1/2. And that's the same thing as multiplying by 1. And so this is going to equal negative 1/2 times the integral. In the place of 4 minus x squared, I'm going to put u. In the place of negative 2x dx, I'm going to put du. And so this is negative 1/2 natural log absolute value of u plus c. You see, all I'm doing is taking this and getting it into this form. And then I know it equals this. And so now I get negative 1/2 natural log, and then 4 minus x squared plus c. All right, this example, well, we got a fraction. Let's see if we take the derivative of the denominator, if we get the numerator. So I'm going to let u equal 1 plus 3e to the 4x. So du, well, the derivative of 1 is 0. Derivative of this is 3e to the 4x times the derivative of the exponent. And so this is 12e to the 4x. Yep, and I forgot I left my dx off. All right. So once again, you can see we've got e to the 4x here. Well, e to the 4x dx, e to the 4x dx. So I need to multiply this by 12 to get the 12 that I need here. And so if I multiply by 12, I've got to also multiply by 1 over 12. And so now I can make my substitutions. So that's going to be 1/12 integral, and that's going to be du over u. Just making my substitutions. This is du, and you can see I've got it here. And then this is u. And so that's 1 over 12 natural log absolute value of u plus c. And then I substitute back in. Plus c. And there's my answer. All right, so last problem. How about this one? Well, let's see if the derivative of the denominator is in the numerator. So I'm going to let u equal 1 plus tangent 2 theta. So du, well, derivative of 1 is 0. Derivative of tangent is secant squared. And then times the derivative of what we're taking the tangent of. So derivative of 2 theta is 2. And when I wrote the problem, I left off d theta. And that would be d theta. All right, so what am I missing? I'm missing a 2 here. See, 2 secant squared. So there's my 2 secant squared. So I got to multiply by 2 in here and come out here and multiply by 1/2. And so this is going to give me 1/2 integral, and that's going to be du over u. Okay, this is du, and this is u. All right, now our original problem was in terms of theta. So now I've got to get this, so that means my limits are in terms of theta. So since I changed my variable to be in terms of u, I have to put my limits in terms of u. Okay? So we've got u is equal to 1 plus tangent of 2 times 0, which equals 1 plus 0 equals 0. That's the tangent of 0, which is 0. And then I have u equals 1 plus tangent of 2 times pi over 8, which equals 1 plus tangent of pi over 4. And so that's 1 plus, and tangent of pi over 4 is 1, so that's 2. So now my limits become 0 to 2. All right, so let's talk about that. Well, remember, this and this is in terms of theta. And I've got to get it in terms of u. Well, what does u equal? U is equal to 1 plus tangent 2 theta. So I take the 0 here and I plug it into theta. That's what I did here. And then I take the pi over 8, plug it in for theta. And now my limits are in terms of u. And so now we can integrate this. So that's 1/2 natural log absolute value of u. Oh, and I'm sorry, that's not 0, is it? That's 1. That's my bad. Okay. See, I didn't, when I did the 1 plus 0, I just put the 0. It's 1 plus 0 is 1. Okay, so this limit becomes 1. My bad. And we're integrating that from 1 to 2. And so this is equal to 1/2 natural log of 2 minus natural log of 1. Well, natural log of 1 is 0, and so that's 1/2 natural log 2. And you can punch that in your calculator, leave it like that. And if you notice, I didn't keep the absolute value. See, I changed the absolute value to parenthesis. Why did I do that? Well, 2's positive. I don't need the absolute value. Okay? So that's just a quick little lesson on when you have integrals and you've got something logarithmic in form, a basic logarithmic form. That's how you integrate them. So I hope the video helped. Check out my other videos. Give me a like, share, and subscribe, and thanks for watching.